All right, so we are going through auxiliary drawings here today and talking about auxiliary views. So learning objectives behind this is, of course, to define the auxiliary views as compared to our principal views. We're going to go into the purposes and benefits of using this. There are relationships between all of these planes and what we're looking at. We'll talk about the use of reference lines in construction of these particular drawings. We'll also describe some techniques that might be helpful for you to visualize these. And we will then also go over some other terms that apply and talk about differences between primary and secondary auxiliary views as well. So these are all some of the things that you need to kind of get familiar with. So first off, what is an auxiliary view? So, well, the idea of an auxiliary view means additional or supplemental. These are ways for orthographic projections to project some angular direction. And again, if you haven't noticed by now, we like to try to find true size and shape of features. So oftentimes, some angled views or some inclined views, even oblique views, we cannot really see true size or true shape because we're not looking directly at it. So auxiliary views are also useful for helping us to get to see a flat surface where we can see true size and true shape. So as we get this, the Ask Me Why 14.3 covers this standard as well. So here we have just an example of the wedge. So now in traditional, the 6 principal views are just your front, top, and side view. We would not really know what the true size and true shape of the inclined surface is. So we can kind of change that by using what we call this auxiliary view principle, where we can project up at an angle in alignment with the actual inclined plane in order to show true size and true shape. So here's an example here of how we would see it from the horizontal and frontal plane. So in this case, we see the front view, we see the top view, and we can kind of, at right angles to that, we can draw projection lines out, and then we can create an auxiliary view that's going to give us true size and true shape of this with everything projected off of there. So oftentimes we will use, when we do this, we use these hinge lines or this type of an idea of a hinge where we can kind of more or less rotate that around. So notice as we take a look at this, the relationship of these different points on here and how they relate to the overall, so that we can see the true shape here as we are rotating looking at this view. We also use auxiliary lines to more or less find what the true angle is. So looking at the front view and top view over here of this part where we see a slot kind of cut out at an angle, from the top view we see the way it looks, but that is not really the true angle. So we have to kind of project over with an auxiliary angle. Notice how we're projecting here from this in order to actually get that true angle and know exactly what that angle would actually be. So as we talk about visualizing some of these views, it's helpful to often take an object and try to turn it in our line of sight and try to picture this in our head as we move these through. Now, for some of you, I know sometimes it's difficult. Not all of us have developed this mind sight, so to say, of being able to identify and look and know what this would look like in our head. So hopefully we'll have a few more objects that we can manipulate around in the classroom so that you can kind of get a better idea of what's really going on here and how we are manipulating these objects in order to be able to see exactly what we need to be able to see. Here's another example of an auxiliary view that is out of the projection line. So notice here our line type that's kind of pointed at this. So where we're basically taking this view and removing it from the actual main object. So, and in this case, this is showing us the true view here as we take a look at that. Because as we look from the front or the side, we don't really see that. Those are inclined planes or inclined surfaces to us. So we have to kind of come up here at, in this case, 37 degrees in order to be able to project that to where it would give us a true size and shape look. So as we take a look further into these primary auxiliary views, so we have what we refer to as a primary auxiliary view. This is the first view that would be being looked at. So in this case, when we see the front view and the side view here, we can tell that this is inclined. One of the ways that we can tell that it's inclined is the shape of the holes actually looks like an ellipse. So we're not, and we know that a hole is not going to be ellipsed, or at least hopefully it's not going to be a ellipse when you drill a hole. Otherwise, you might have some other problems with the machine that's drilling the hole. But so in order to tell what the true size and true shape is, we project into an auxiliary view. So imagine our hinge line would be kind of going right through here parallel to that particular edge, and then we can more or less move that on the hinge to see. Now you can see from this example here that auxiliary view now shows us the true size and true shape here, and it also gives us a good way to be able to actually put some tolerances on and actually know exactly what these dimensions should be and where the placement of those holes should be on that part. So we have a couple more terms that we need to go over here. So depth auxiliary view, height auxiliary view, width auxiliary view. Basically, as you start to think about this, think about which of the main views so are not showing that depth or height or width. So if you think about it from the depth view, we see depth in both the top view and the side view. So since we see depth in the top view and the side view, any depth auxiliary view is going to be projected from the front view. So, and when we talk about height, so when we see height, we can see height from the front view and from the side view. So any height auxiliary view is going to be projected from the top view. Width, of course, is exactly kind of the same way. The width auxiliary view, we see width in the front view and the top view, so it is projected. A width auxiliary view then is going to be projected from the right side view. So here's an example of our secondary auxiliary view. So we have what we call a primary auxiliary view that could be projected from any of the front, top, or side planes. And then we have what we call a secondary auxiliary view. So, and this is what's used predominantly for identifying true size and shape of oblique surfaces. So as you can see here, first it is projected off of one of the views so that you kind of are getting one edge view there, and then it's a second projection off of that. So here we've got the edge views coming into here to kind of identify all of that with the primary secondary view. So notice the correlation again of the points as we take a look at it, and then from that view we can project once again. So we wanted to see the edge view here, so when we were projecting that off then, and everything kind of comes down, and notice the relationship here of how we're putting those points together to get these views rotated around in our head. All right, when we talk about computer-generated auxiliary views, obviously the computer has made this a lot easier for us to be able to look at and manipulate parts around. So it definitely gives us a better understanding of what the actual part looks like, especially when we're talking about solid modeling on a computer. However, sometimes when we're putting that onto an actual print, it does require some additional manipulation on the part of the drafts person that's working in the CAD system to make sure that everything comes out looking the way it's supposed to be looking. But for the most part, these 3D CAD tools have made it very easy for a designer to communicate these different ideas with our auxiliary views, and I will show you an example of that here a little bit later today in class. So that is the basics here of auxiliary views. We'll be going through this pretty quick as you help to start to visualize what these look like. And I'm going to bring a couple of other CAD drawings in just to help you be able to manipulate this in your mind's eye.